Good morning, guys. Welcome to today's lesson, May 5th, factoring GCF and DOTS. Let's take a look at our do now. So the first one we have to divide. All right, you see that division bar? We have 18x to the 8th, y to the 10th, divided by 3x to the 7th, y. And remember that y is to the first power. What we got to do first, divide your coefficients, those numbers out front. So 18 divided by 3, which is 6. And then we need to deal with our x terms. So x to the 8th divided by x to the 7th. Remember, you keep your base, the variable x, as that base, and you subtract your exponents. All right, remember, if it was multiplication, we would be adding those exponents, but division, we subtract them. So 8 minus 7, which is 1. You don't write an exponent of 1. You can if you want, but it would just be x to the first power. And now same thing for our y's. Keep the y, and then subtract your exponents. So 10 minus 1, which would be 9. And that's it. So just dividing some monomials. All right, next, we're multiplying two binomials, 3x plus 4 and 3x minus 4. They look very, very similar. All right, but let's see what happens when we multiply them. Remember, we set up the box method. We have a 2 by 2 box because it's a binomial and binomial. 3x plus 4 and 3x minus 4. So 3x times 3x is 9x squared. Remember, exponents, right? 1 and 1. Add those together, you get 2. 3x times negative 4 is negative 12x. 4 times positive 3x, 12x. And now 4 times negative 4 is negative 16. Now there's a special relationship between a binomial 3x plus 4 and 3x minus 4, or if it was like 2x plus 5 and then 2x minus 5. Okay, you see what happens here? Those x values, those terms with x in it, they cancel each other out. They're opposites of each other. It would be like 12 and negative 12. 12x, negative 12x. All right, it would be, I don't know, 50y and negative 50y. They cancel each other out. Now, you could write it out, but just for time's sake, you can see that we just get rid of those. All right, so the only thing you're left with is 9x squared and minus 16, and you're done. All right, next, 3. More multiplication. It's a term in front of parentheses. Anytime you have a term in front of parentheses. Now, if it said like 6x plus something, all right, we wouldn't be distributing that 6x. Notice how the 6x is literally attached to that set of parentheses, so you have to be multiplying. All right, it says, this tells you a term next to parentheses says distributive property, so 6x goes to everything on the inside of the parentheses. Now, if there was something on the outside, like something like that, you wouldn't take the 6x to that 2x. It's not in the parentheses, and it's also there through addition, not through multiplication. All right, but anyway, so 6x times x squared is 6x to the third power. Once again, remember that's an exponent of 1 for that 6x. 1 plus 2 is 3. All right, next, 6x times 3x is 18 positive, right? 18x to the second power. Once again, another exponent of 1. 1 and 1 makes 2. All right, and 6x times negative 4 is negative 24x. Now, are these any like terms? You see a lot of x's, but not with the same exponent, so they're not like terms. All right. Now, list the 12 perfect squares. Now, when we talked about simplifying radicals, we did talk about some perfect squares. So what's a perfect square? All right. Essentially, start with your numbers, like the number 1. Multiply 1 by itself. Okay, 1 times 1. That's 1. That's a perfect square. And 2 times 2. 2 times 2 is 4. 3 times 3 is 9. Now, what makes them a perfect square is when you take the square root of one of them, like for example, the square root of 9, you get that equals to 3. Why? Because 3 times itself, right? 3 times itself equals to that 9. Alright, so essentially a perfect square is just something that there's a number that you can multiply by itself to get that value. Okay, just like 4 times 4, that's 16. Right, so we took the square root of 16. There's a value, right, something times itself, that gives us 16. Alright, 5 times 5 is 25. 6 times 6 is 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. 12 times 12 is 144. So those are your perfect squares. Now there's also perfect squares in terms of variables. All right. The way that goes, if the exponent for that variable is an even number, so 2, 4, 6, 8, 10, all right, if it's anything even, it's a perfect square. For example, x squared, that's a perfect square. X to the 4th power, that's a perfect square. Why? Because something times itself gives you x squared. What is that? X times x. Something times itself gives you x to the 4th. Because x squared times itself, x squared is equal to x to the 4th. Alright, so anything, now it doesn't have to be x, guys, it could be y, z, w, whatever. Alright, x to the 8th, x to the 10th, and these go on forever. X to the 12th, you can keep going and going and going and going. You can also with the, your numbers here too. It keeps going. Alright, these are mainly what we'll be dealing with today. And once again, where does this come from? For example, x to the 10th. It's because x to the 5th times itself, x to the 5th, gives you x to the 10th. Just remember, you're adding exponents here. 5 and 5 makes 10. Well, before we did 2 and 2, that makes 4. Right? 1 and 1 makes 2. Alright, so factoring. Alright, factoring is breaking an expression down into factors, terms that multiply back to the original expression. So what are 2 factors of 20? So that we're saying, what are values that multiply to give you 20? Maybe 5 and 4. Right? Maybe 1 and 20. Right? Multiplication. 1 times 20. That gives you 20, right? Or 2 times 10. Okay? Just values that multiply to give you 20. The same thing works for expressions, guys. We're going to break it down to 2 things that are going to multiply to get the original expression. All right? So when you're factoring, if you remember this from Algebra 1, remember this is all geared towards you refreshing on your Algebra 1 skills. The first thing you always look for is GCF factoring. Greatest common factor. So essentially, what's the largest value? All right, that can divide evenly into the original expression. Okay, so you see your steps here. Find the GCF, divide all terms by the GCF, express your answer as a product of the GCF and the divisor. So the divisor is essentially like when you divided it, what resulted. All right, so watch. Ready? 3x plus 6. What's the biggest value GCF-wise? All right. What's the biggest value that divides into both terms? So there's 2 terms, 3x, and then there's 6. What's the biggest value that divides evenly into both of those terms? I always check for my numbers first. So between 3 and 6, what's the biggest value that divides into 3 and 6? It's 3. All right. It's 3. Now, there could, part of your GCF could be a variable, but notice how the 3 has a variable and the 6 does not, so you definitely know that there's not going to be any variable included in your GCF. So what you do now, you divide both terms by the GCF. And then what you do is you do 3x divided by 3. 3x divided by 3 is just x. And 6 divided by 3 is just 2. So we have x plus 2. Now, a lot of students forget to do this. that, remember, it's a product of the GCF and the divisor. Okay, so you have to write the GCF out front, sort of like the distributive property. Okay, so this right here is your final answer. So it's a product of the GCF 3 and what resulted from the division, which was x plus 2. Now just see this, right? If you take 3 times x, what's 3 times x? 3x. And what's 3 times 2? 6. You get that original. Or you get that original value that we got. So if you go ahead and, sorry, I forgot to use an arrow here as well. All right, when you go ahead and multiply it out, working in reverse, you see that we get the original. So it's a good way to check your answer. All right. Okay, next, 2 here. All right, guys, this is a review. If at any point you want to pause the video, go for it. You can try these on your own, and then you can come back and look. All right, but your GCF in the next one. I like to write the GCF off to the side. Now, look at the values first. So the numbers, the numerical values, right? 15 and 5. What's the biggest value that goes into 15 and 5? It's 5. Now, both of these terms have an x term. So it's x, I have an x variable, right? X to the second and x to the first. So essentially what you do with the variables, you just look for the highest value essentially for that variable that is common for both. So the highest exponent that's common for both. Is 2 common for both? No. 1 is common for both. So 1 is going to be x to the first power is the value you're going to use in your GCF. So if it was like x to the third and x to the fifth, we would use x to the third. All right? Because remember how this really is. X squared is really x times x. And x over here to the first is just x. So it's essentially saying how many x's are in common for both. All right, only one x is common for both. So that's why it's x to the first power. All right, so now let's divide both terms by the GCF by 5x. Remember, you have to throw your 5x on the outside of the parentheses. You'll start to do that at the beginning. Okay, so now 15x squared divided by 5x, that's 3x. And 5x divided by 5x is 1. Anything divided by itself is 1. And you're done, but just see how you can check your answer. 5x times 3x, that is 15x squared, and 5x times 1, that is 5x, so you get your original expression. All right, next, so now we got a couple variables. So your GCF, right? What's the GCF between 2 and 4? The biggest number that goes into both 2 and 4 is 2. All right, now look, you have y to the first power and you have x to the first power over here. So how many x's do we have common in both expressions, both terms rather? X to the first power. How many y's are in common? It would be y to the first. All right. So you get 2xy, that's your GCF. Divide each term. Good to throw the GCF out front at the beginning. So now 2x squared y divided by 2xy, right? Your 2's are gone. 2 divided by 2 is 1. Y divided by y is 1, so those are gone. So it's essentially left with x squared divided by x, which is just x. All right, plus, for our next term, 4 divided by 2 is 2. X divided by x, that's gone. All right, that would just be 1. And then y squared divided by y is equal to y to the first power. Done. So 2xy times x, does that give you 2x squared y? It does. And 2xy times 2y does give you 4xy squared. Good. Alright, so you can go back and multiply it through the distributive property. Alright, and you can see you get the original. Next, what's the GCF for number 4? X squared minus 4. Think about that for a second. Now, there is none. Alright, there is no GCF. So now we have a different kind of factoring. Always look for GCF first, but look, the coefficient right there, the number in front is 1. So between 1 and 4, or negative 4, there is no common factor. Okay, the only factor is 1. Alright, so we're not going to bring it out and multiply by 1. You multiply by 1, you get yourself. Alright, so there's no common factor between the coefficients of 1 and 4, and there's also no common variable. Alright, one term has x to the second, and the other term doesn't have a variable at all. So there's no GCF. There's a different type of factoring, but for those of you who remember, this would be x minus 2 and x plus 2, and now that probably doesn't make sense right now, but let's talk about what we have to do with our next type of factoring, which is dots. Maybe you remember what that stands for. It's the difference of two squares. So we're dealing with those perfect squares, we're dealing with those square roots, right, that we discussed here. So it's when both terms in the expression, now it has to be for a binomial, a two-term expression. There's only going to be two. If you're going to use dots, it has to be for two terms, which this is two terms. Alright, so you're taking the square root of both of these terms. Alright, so 9x squared, right? You see that. Now, what times itself gives you 9x squared? Alright, well, this is me just breaking it down off to the side. You don't have to do this every time. But essentially we're saying, what's the square root of 9? What times itself gives you 9? 3. Also, what's the square root of x squared? Right, what times itself? Right, what times itself gives you x squared? X. So it's just 3x together. Right, this is multiplication. Multiplication, when you write something like 3x. So 3x times 3x gives you 9x squared. And same thing for 16. Off to the side. Square root of 16 is 4. Now how you write it, you might remember from Algebra 2, you write, when you use dots for factoring, you write it as two binomials, the product of two binomials. Alright, so you have 3x and 4, and 3x and 4. However, when you do this, alright, one of your signs has to be a positive, and one of your signs has to be a negative. They have to be different signs. It doesn't matter the order. You could do negative first and then positive. Alright? Hopefully you're seeing how familiar this looks. Remember when we multiplied these together, guys? In your do now today? We multiplied that out. We got that exact same answer. We used the box method. 3x plus 4 times 3x minus 4. And you got 9x squared minus 16. Alright, just to show you that it works. Okay. Next. This is dots. Okay, why? Because these are perfect squares. 25, right? 25 is a perfect square. Y to the 8th is a perfect square. 9 is a perfect square, and x squared is a perfect square. Alright, we're dealing with nothing but perfect squares, and it's the difference, so subtraction, right? Difference means subtraction. Alright, so you have to make sure that there's subtraction in the middle of the two terms. So if this was a plus sign, you cannot use dots. Alright, it has to be subtraction. Alright, so maybe pause the video now and see how you do for a problem like this, and then come back. But if we're taking the square root of 25y to the 8th and 9x squared. Once again, you can think of this as two different values, radical 25 and radical y to the 8th. It might be easier to look at that way. And radical 9 and radical x squared. But this would be 5, because 5 times 5 is 25. And this would be y to the 4th, because y to the 4th times y to the 4th gives you y to the 8th. You'd be adding exponents. 4 and 4 makes 8. All right? And this would be 3. 3 times 3 is 9. And x. X times x is x squared. All right? So you write it as two binomials, the product of them. So it would be 5y to the 4th and 3x. 5y to the 4th and 3x. And remember, you have to have a plus and a minus. And that's it. You're done. Remember, if you multiply that out, you could try it using the box method. If you multiply those two out, you get the original. Okay. Challenging ones. 5x squared minus 20. Why this is challenging? Did you check for GCF first? All right. There happens to be a GCF, so we have to use GCF factoring. Now, just because we're working on dots here, all right, we're getting right into it. We're like, all right, dots, great. Here, you really, every single time they request that you factor, you have to check for GCF first. There is a GCF, all right, between the two terms, and in addition, 20, that's not a perfect square. That's not even on your list, so the difference of two squares, no go. All right, there is a GCF, and it happens to be, remember, check for the numbers first, 5 and 20, it's 5. So you have to divide both of these by 5. 5 goes on the outside. So 5x squared divided by 5 is x squared. Now there's a minus sign up top, so you keep minus. All right, so it's like saying negative 20 divided by 5, which is negative 4. Now what also makes this problem difficult, well, first it's that you may have been like right into dots. All right, you have to do GCF, but then also that x squared minus 4, those are two perfect squares. X squared is a perfect square, and 4 is a perfect square. Check your list. All right, 4 is a perfect square. Yep. X squared is a perfect square. That's two perfect squares. So there's dots involved. All right. So the 5 stays out front, but then the binomial x squared minus 4 has to be written as a product of two binomials. All right. The square root of x squared, what times itself gives you x squared? It's x. Now, what times itself gives you 4? That's 2. One positive sign, one negative sign. So there was two types of factoring here. You might remember your Algebra 1 teacher saying factor completely. So you just keep factoring until there's nothing left. This is a combination. This is a great, guys, a really great problem to look at. All right, because it involves GCF and it involves dots. All right, and one more here. Is there a GCF? Check for that first. No, there's not. Remember that coefficient is 1, 1 in 16. Nope. All right, one of them has a variable, one of them doesn't. There's no GCF. So for dots, this is dots because these are two perfect squares. Product, two binomials. So what times itself gives you x to the 4th? That's x squared. What times itself gives you 16? That's 4. one positive sign, one negative sign. And we're not done. X squared minus 4. Alright, this right here, x squared plus 4, cannot be factored because there's a positive sign. However, this is the difference, subtraction, this is the difference of two squares, two perfect squares. Alright, so you can factor that. So what you would do, you would just rewrite the first term, x squared plus 4, and then we'll have two sets of parentheses to finish this off. Remember, this would be x times x would give you x squared, 2 times 2 would give you 4, one positive, one negative sign. Now you're done. So this was dots twice. Alright, these are two examples of factoring completely. One of them was GCF and then dots, and the next one was dots twice. Alright, so definitely, I mean, full-blown review from Algebra 1, but this is really like the foundation. Factoring is huge in Algebra 2. There's so many times where you have to factor to complete another goal. So make sure that you have this down pat. Ask me questions and remind. Complete your Delta Math, that is posted, and it's a lot of this Algebra 2 practice type stuff. Alright, have a wonderful rest of your day, and I will see you mañana.